Our today's topic is method of undetermined coefficients. We are going to solve higher order linear non-homogeneous differential equations with constant coefficients. Last time we did almost the same with the difference that we did homogeneous. In homogeneous case we have a 0 on the right hand side, and in the non-homogeneous case we have a g of x on the right hand side, which is a function of x, non-zero. It can be a constant, of course. For example, let's say our equation is y double prime plus 3y prime plus 2y equals 6. So here our g of x equals 6, which is not 0. So this equation is non-homogeneous. So how do we solve this non-homogeneous equation? We already know how to solve the homogeneous equation. So we will divide this question into two parts. We will write the associated homogeneous equation. So we will write y double prime 3y prime plus 2y equals 0. So that is the associated homogeneous equation. We are going to put a 0 here for 6 and solve it. And this solution of this equation, we call it complementary function, and we denote it with yc. Then we write the same equation again with 6, and then we solve it again, and solution for this we call it particular integral. No need to remember the names for now. And then and then we make a final solution, general solution, by adding yc and yp. We already know how to find yc for this. So for yc, we write auxiliary equation m square plus 3m plus 2 equals 0, which means m equals minus 1 and minus 2, and this means yc equals c1 e raised to power minus 2x plus c2 e raised to power minus x. Now for yp, we need to start with a supposed solution. So first we let that yp is equal to this. Okay, how do we let? What hint do we use? How do we find out what should be the starting yp? There are some standard hints in literature that will work for us, and they depend on g of x. Okay, this 6 we have here. So it depends on g of x what you should start for yp. Our g of x is constant. Okay, so it means we can look at the list. Let me copy the list into the notes for reference. Right. So this is the list. If our g of x is a constant, then we start yp with a constant a, we can say. If our g of x is a linear equation, linear polynomial, then we start with a linear polynomial. If it is quadratic, highest order of the variable we are looking at here. If it is a quadratic, we start with quadratic, and also note, even if we do not have x here, we still put the x here. Okay, so 3x squared minus 2, we start with ax squared plus bx plus c, and also all signs are positive, although this minus 2, 2 has negative, but we have C as positive. Again, the same, cubic is the highest power, so we write the complete general cubic. No x square, but still we have x square. So in our case, it is very easy. It is simply a, because our g of x is 6, constant. So that comes in first category, right? So if yp is constant, then what next do we need to do? Because now we are going to use, first we put it equal to 0 and find yc, okay, so that we have got one solution, which is the homogeneous part solution. Now we are going to use complete equation with equal to 6. So how do we use it? We have supposed a solution. We will take two derivatives and substitute into the equation. Okay, so let's do that. Yp prime equals 0 because a is a constant. Yp double prime is a 0 again. Now we put the values into the equation. Y double prime plus 3y prime plus 2y equals 6. We put yp in place of y. Okay, don't worry. P is just a indicator for our solution type. So this is 0, 3 times 0, 2 times a equals 6. That means 2a equals 6 and a equals 3. So that also means that our yp equals 3. Now we have both the solutions. We can write our general solution. Yc plus yp equals c1 e raised power minus 2x, c2 e raised power minus x plus 3. No constant will be attached with yp because this is a particular solution already. Okay, it does not need any constant. But do note that it's a second order equation. It's a second order equation. It has two unknown constants because we are not given any initial conditions or boundary conditions. So we cannot find these constants for now. They will remain unknown constants for this question. Our next example is y double prime minus 10y prime plus 25y equals 30x plus 3. So once again, for yc, as the equation is non-homogeneous, it has two parts. For yc, we write the equation equal to 0 and we call it associated homogeneous equation. And this equation gives us auxiliary equation, which is m square minus 10m plus 25 equals 0. And that auxiliary equation will give us roots 5 and 5. And from that we can write our yc, which is c1 e raised power 5x plus c2 e raised power 5x. But no, there is something missing in this one. When the roots are repeated, we do something extra with the second solution. What is that? We multiply it with x. c1 e power 5x plus c2 x e power 5x when the roots are repeated. So that is our yc. Now for yp, we have to start with our g of x. Okay? g of x is 30x plus 3. What kind of g of x is it from the list? G of x is the second type, linear polynomial. So it means we will choose yp to be ax plus b. Always these constants should be general. Don't use 5 and 7 on this side, please. Okay. So we will never use these constants here. we will find them by taking the derivative, substituting into the equation, and then comparing. Okay, we find a, b, c by this process. If we fix them already, like if I use 5 and 7 here, then there is nothing to find. Okay, so we will start with ax plus b. Ax plus b. We need two derivatives again because there is y prime and y double prime. So we find two derivatives. Y prime equals a, yp double prime will be 0 because b is constant and a is also constant. So y double prime minus 10y prime plus 25y equals 0, not 0. Now we are doing the non-homogeneous part, equals 30x plus 3. And now we put the derivatives. Y double prime is 0 minus 10 times this one is a, 25 times this one is ax plus b, and that is equal to 30x plus 3. So how do we find our a and b then? On the left hand side, let us write it in standard form. So let's write 25ax minus 10a plus b equals 30x plus 3. We can see that this term has x, okay, and this is the coefficient of x. These two terms, they are constants. On this side again, we can see that this term is a coefficient of x. It has x in it. Okay, so this is coefficient of x, and this term is a constant. Okay, how does it work? We call it comparing coefficients, and that's where the name of the method comes. Comparing coefficients. Okay, if we have, let's say, a, let me write in the same order as it appears here. So if we have ax plus b equals 3x plus 4, how can we find a and b from this expression? Very clearly, we compare coefficients of x, that means a equals 3, and we compare constant, that means b equals 4. There is no other possibility for a and b here in this equation. The only possibility is that we compare x, and then we compare constants. For example, if this equation was like this, let's say 7, okay, I'll write a and b on this side, a e power 3x minus plus b, or minus 3b maybe, minus 3b x equals 7 e power 3x plus 10x. What are the variables here in this equation? The variable is e power 3x, and we have e power 3x on this side. The second variable is x, and on this side we have x. Let me add one more thing into the mix, plus 4 maybe. No? Okay. No. Better don't. Right. Now we compare e power 3x separately. When we compare e power 3x separately, we get a equals 7. Please note that we are only comparing the coefficients. We are writing the coefficients here, not the variable again. Okay. If we compare x from here, we get minus 3b equals 10. And again note, I'm not writing x here in this result because I'm comparing coefficients, and coefficient of x is 10. X itself is not the coefficient. So minus 3b equals 10. So this is how comparing coefficient works. We choose separate functions. First we look for different terms and we point out separate functions, different functions, and compare their coefficients one by one. Each function will give a separate equation or result. We say comparing coefficients of x. What do we get? 25a equals 30, and that means a equals 6 by 5. Comparing constant terms, that is the constant term here is minus 10a plus b, and on this side the constant term is 3. Now we know the value of a already. We put the value of a here, minus 10 times 6 by 5 plus b equals 3. And now this is a very easy calculation that will lead to b equals 3 by 5. Now we know our a, we know our b, and we can write yp equals ax plus b. So that becomes ax plus b, that becomes 6 by 5x plus 3 by 5. Our final solution, general solution again, because we are not given any initial conditions. So it is c1 e power 5x, c2x e power 5x plus 6 by 5x plus 3 by 5. That completes solution for this equation. Alright, our next question is y double prime minus 4y equals 7 e power 3x. Once again, same routine. For yc, we consider the associated homogeneous equation, which means equals 0. M square minus 4 equals 0. And that means m equals 2n minus 2. That gives us yc equals c1 e raised power 2x, c2 e raised power minus 2x. For yp, we have to suppose a yp. Let's go back to our list. There is no e I have copied there, so let's copy the e part from here. Right. So we have done already the first 4. We did example for first 2. Third and fourth are exactly the same. It will only be a slightly bigger function. And now we have number 7. So yp, we have e power 5x. For example, we have something like this. E power some number. So we suppose yp equals a times e power the same. Same 5x is same as 5x here. But this constant we do not use. Okay, the constant which is multiplied here we do not use, just like we did not use 30 and 3. Okay, and we did not use 6 here. So, but this power, because that defines the function, that we will use. Okay, and once again we need two derivatives because it's a second order equation. Yp prime will be 3a e power 3x. Yp double prime will be 9a e power 3x. And that leads us to yp, not yp. You can write the equation with yp here if you would like, but not very necessary. 7 e power 3x, yp double prime is 9a e power 3x minus 4a e power 3x, 7. So we substitute the values of y double prime. This is y double prime, this is y prime, okay? And now we go for the comparing coefficient step. This is same functions, so we can uh, simplify the coefficients. So this will become a 5a clearly comparing coefficients of e power 3x as I have explained earlier in this example. So if we have same function on both sides, we compare coefficients of that function and we can write a equals 7, like for example here. So in this case we get 5a equals 7. That means a equals 7 by 5. I'll write y directly this time. We know the story. C1 e raised power 2x, C2 e raised power minus 2x plus 7 by 5 is our yp. Our next example is this one. I am modifying questions from the book slightly because we are not going to discuss all the cases of undetermined coefficients. Right, for yc, for yc we have equals 0. The auxiliary equation will be m square minus 7m plus 12 equals 0, and m will be 3 and 4. Yc is c1 4x. And for yp, well, this time we have slightly different story. We have two functions on the right side. One is 3x square, which has a separate group. 3x square is a polynomial. It's here. For 3x square, we must write ax square plus bx plus c, even if there is no x or constant in our case, no x and constant, but still we must write the complete quadratic expression here. And the second is e power x. So we have two groups from this thing. So we will treat them separately. We will treat them separately. For 3x square, we will write ax square plus bx plus c. And for e power minus 2x, we must write a e power minus 2x. But there is a little bit of problem. We cannot repeat the constant a in the same expression because we are going to add them together. We cannot write a 2 times. where a is multiplied with x square, here a is multiplied with e power minus 2x. That will not work. So that we cannot do. We must write a new constant d for e power minus 2x because we have already used a, b, and c. So next we will write d for e power minus 2x. If we had, for argument's sake, we suppose, if we had sine or cos here, we will start with e and f and so on. So our yp in this case is yp ax square plus bx plus c plus d e power minus 2x. Okay, and once again we need two derivatives of it. Yp prime 2ax plus b minus 2d. Again, please remember this minus, we do not use minus, we use plus here. And this constant minus 1, we don't use it here, only the power because that defines the function. Yp double prime 2a, b becomes 0 again, minus, because plus 4, another minus 2. Now we put the values into the equation, y double prime minus 7y prime plus 12y equals x square minus, was it x square? 3x square, e raised to minus 2x. Y double prime, which is 2a, okay, 2a plus 4d e power minus 2x. 7 times y prime, it is 2ax plus 12 times constant y, which is ax square plus bx plus c plus d e raised power. And on the right hand side we have 3x square minus. Yes, these questions can get very lengthy at times, especially we are not going to do all the options here, all the cases here. Right, what variables do we see here? We see x square, we see x constant, e power minus 2x. Okay? There are 4 kinds of variables. So let's collect all the terms. First, let's expand the brackets, all of them. So it is 2a plus 4d e power minus 2x minus 14ax minus 7b plus now let's collect the terms. X square, this one is x square, and that's it. X square is the only term here. I'll use red for constant because that's the most terms. 2a here, minus 7b here, 12c here, that's our constants. Let's use blue for x, x here, and here, these are. And let us use maybe green for x square. So this is our x square, only term on this side. And e power minus 2x is very clear, no need to point it out. It can be seen easily. So let's start with x square, which is only term is 12a x square plus x terms, these two. Okay, I'll write them with minus 14ax plus 12bx constants 2a minus 7b plus 12c, and then I will write e power x terms, which is 4d e power minus 2x. Second one is 14d e power minus 2x, and the third one is 12d e power minus 2x. Actually, no need to do this step. I'm just doing it because it's the first time we are doing this problem. You can write the directly what is the combination of these. So, well, especially in this case, because you can add them, it's the same variable, and you can write collecting all these together. Collecting uh, all these together, you can write 12 and 14, 26 and 4, 30d 30d e power minus 2x. Okay, these three is 30d e power minus 2x. All right, now we compare coefficients of x square. Okay, if you pay little attention, you can do this step, the comparing coefficient step, directly from here. Okay, directly from here you can easily see where the x square is, where x is, so you just have to write the coefficients. So no need to waste your time on just collecting the terms, and you can do directly from here. But anyways, comparing coefficients of x square, on the left hand side it is only 12a, one term, 12a. On the right hand side it is 3, so that very nicely gives us the value of a. I'll keep only this picture in this in picture. Now we say comparing coefficients of x. So x is minus 14a here. Right, comparing coefficients of x, minus 14a plus 12b on the left hand side. And on the right hand side, we see that there is no x here. Okay, as you can see, there is 3x here and e power minus 2x, but no x here. So that will be a 0. Okay. And now we can use value of a here, and this will be let us first write our equations, all of them. So comparing constant terms, which will be constant terms on this side is 2a minus 7b plus 12c equals, and on the right hand side there is no constant term, there are only two functions, so again 0. And then we compare coefficients of e power minus 2x. On the left hand side, these three terms are the coefficients of e power minus 2x. All three are plus, so they make 30d on the left hand side, and on the right hand side it is only minus 1. Now we will put a here and find b. Okay, so I'll leave this one for you, so it's very easy to find out. So b will become, as for my calculations, it is 7 over 24, and now we put a and b here in these two places, and then solve for c. And according to my calculations, because I started the question almost without any thought to the values of the constants, so they are getting like slightly bigger because of the 7 and 12, and d from here will be minus 1 over 30. That completes our yp. Ax square 1 by 4x square, bx 7 by 24x plus c 37 by 288 plus d e power minus 2x, and of course our general solution is yc plus yp, and that is equal to, well, I'll leave that step for you, and that completes our question.